So there is much uncertainty and disagreement out there about AI risk and more generally about how AI will develop in the future. In such a situation, it's natural to ask, what do AI researchers themselves think about this? And in response to that natural thought, there have been several surveys questioning AI researchers about aspects of the future of AI. And what I'm going to talk about here today is the best such survey or series of surveys. They've been conducted by Katja Grace in Berkeley, together with various collaborators. The first such survey was carried out in 2016. This was followed by another one in 2022 and yet another one in 2023, which was reported only last week in this paper on thousands of AI authors on the future of AI. Now, you can see that these years, 2016, 2022, and 2023, are not exactly equidistant. And I interpret this as Katja Grace thinking in 2023 that so much has happened over the past year that it really makes sense to look into how the views among AI researchers have been affected by the very, some would say, dramatic developments in AI that have been taking place. I think these surveys are very interesting and that there is a lot to be learned from them. However, there are a number of reasons why I think that they should not be taken as authoritative or reliable sources for prediction about the future of AI. So I'm going to mention one result from the latest 2023 survey and just tell you how not to interpret this. So this is a diagram comparing the timelines that AI researchers have in 2022 and in 2023 regarding when we should expect what they call HLMI, high-level machine intelligence, which is carefully defined by Grace and co-authors. High-level machine intelligence is achieved when unaided machines can accomplish every task better and more cheaply than human workers. They ask the respondents to ignore aspects of tasks for which being a human is intrinsically advantageous, such as being accepted as a jury member, which the law requires that you are a human for that, of course, but we should not count such artificial restrictions against the machines. Think feasibility, not adoption. This is from the questionnaire. And the respondents are asked to give probabilities at 3 different time points, and then a curve is fitted. All the weakly marked curves in this diagram are individual examples, and the thick blue line here is the 2022 aggregate forecast, a kind of averaging of all the responses, and the red one here is the one from 2023. And there you can, for instance, read off a probability. If you want to know when is there a 0.5 probability of human level machine intelligence, the thick red line here indicates something like 2046, I guess. But what I want to warn against here is to interpret this as kind of the scientific consensus estimate. Given the best knowledge we have, we should expect high-level machine intelligence in 2046. I don't think that's a reasonable interpretation. We should make the weaker interpretation that this is the median estimate among more or less well-informed AI researchers, and that can be interesting in its own right, and it can also maybe serve as an input when we think about what is actually the best estimate here, but it does not in itself constitute the best estimate. So why am I so skeptical about that here? Well, there are a few reasons. One reason is that doing surveys like this is kind of letting the researchers vote on what the ground truth is. That's really not a good way to settle scientific questions. There are deep scientific questions here about how feasible or how difficult it is to achieve high-level machine intelligence, and just we don't settle such things by voting. Another reason is that there is kind of a mismatch between the expertise of the respondents and the expertise that is required to answer these various questions about the future of AI. So the respondents mostly work on research geared towards AI development. But the questions in the questionnaire here concern AI futurology, predicting what will happen with AI in the future. And that's a different thing. And sometimes when I'm in a confrontative rhetorical mood, I say that thinking that these AI development-oriented AI researchers, thinking of them as the experts on AI futurology, that's like if you want to understand the future of agriculture, you should just make a survey among farmers and ask what they believe about the future. Well, it can gain some insights, but it's not really an authoritative source of the best evidence for what will happen in the future. Furthermore, when we look closer at the survey results, they give very strong indications that many of the respondents have not really given the topic much thought at all. And this is not just because I disagree with some of their responses, but whether or not I do, there are internal inconsistencies in the responses given, and I will come back to that. But before that, let me mention that the breakthrough regarding public visibility of these surveys by Katja Grace and her collaborators came in April 2023, when Max Tegmark, in an article in Time magazine, pointed to a result from the 2022 survey. The 2023 one wasn't out yet. He pointed to a result in that survey and argued his case for taking AI existential risk seriously. What he pointed to was a 10% median response among AI researchers to the question of how likely they consider human extinction as a result of AI to be. So what Max says here is something like this. Imagine a field where half of the researchers give a 10% or more probability to the event that the work of this field will eventually lead to the extinction of humanity. Isn't that a really, really weird situation? And it's noteworthy exactly how to interpret the situation. I will come back to, but I want to mention that Max Tegmark received quite a lot of pushback and criticism for this use of the statistic. People objected to the validity of this 10% figure, and there was a lot of this in social media, and it was picked up by leading Swedish science journalist Maria Günther, writing in the Swedish newspaper Dagens Nyheter. And I'll quote from the headline. She says, no, every second AI researcher does not think there's a 10. It's not the case that every second AI researcher thinks there's a 10% risk of humanity going extinct from artificial intelligence. And I think that there is some validity to the criticism of this 10% number, but the headline here goes totally overboard because there is no alternative fact. No, it's Günther doesn't really make a case that the true number should be less than 50% of AI researchers. And this is not a matter of some editor exaggerating in the headline, but she says more or less this inside the text of the article. I'll translate this for you. Sure, it's important that we discuss consequences and dangers with AI development, but could it really be the case that as many as every second AI researcher, and she repeats, every second AI researcher sees such a large risk of humanity going extinct because we're unable to control AI? And she says, the answer is simply no. And here she actually goes entirely overboard. She's nowhere near establishing such a no question. But let me return to her criticism and what it's about. Well, her argument is about a large non-response rate in the survey. So of the a little more than 4,000 researchers who received the survey, the response rate was only 17%. And in fact, she says only 4% responded to this particular question, so that leaves only 162 respondents and a non-response rate of 96%. And a non-response rate of 96%, that sounds devastating. But as a matter of fact, going from 17% to 4% here is not a matter of individual respondents choosing not to answer the question, but this is a consequence of this being a large survey and Grace and her collaborators having chosen to just assign random subsets of questions to each respondent, which is a very good idea to do when you have a large number of respondents and a large number of questions to optimize the amount of information you can get from there. So the kind of bias that you get non-response. The relevant figure here is not the 4% she talks about, but 17%. Having as few as 162 respondents, it does increase the statistical uncertainty a little bit, but it's good enough to estimate within a few percentage points, approximately the number of the percentage of people subscribing to a 10% or higher risk of human extinction. Now, so the non-response rate here is 83%. You can complain that this is bad, but this is very normal in social science. If it's the case that responding to the survey and answering, giving a particular answer to a specific question, if those things are uncorrelated, then actually the non-response, the higher non-response rate is not much of a problem at all. And it's only when you see such a correlation that it happens. So in much of the pushback against Tegmark's article, it was assumed that people who were interested in existential risk and judged that risk to be large would be obviously overrepresented among the respondents. But actually the survey was carried out quite carefully so that the respondents, when choosing whether to participate or not in the survey, received no information about the particulars about the question. They had no indication that it would be particularly about existential risk from AI. So one could argue that it would have been good if Max Tegmark had pointed out that there was a large non-response rate. It would also have been good if Maria Günther had not presented her case in such a misleading way in Dagens Nyheter. But even, I mean, it's not at all clear we should expect a correlation. And even if it turns out that there's a really, really strong correlation one way or the other between responding, taking part in the survey and giving a particular answer to this question, well, with a quite strong such correlation, maybe the 50% figure that Max Tegmark talked about for the proportion of AI researchers giving this high estimate of risk of human extinction, this 50% number, it could be 70% or it could be 30%. I mean, that's those are, that could be, but it really doesn't change Max Tegmark's argument very much that it's a strange situation where you have a research profession, a research discipline, where a substantial number of the researchers working in it assign a non-negligible probability to the entire research endeavor ending up in human extinction. It's still an interesting situation. So I want to mostly defend Max Tegmark here and say that, okay, it was a kind of sloppiness that he didn't point out the high non-response rate, but it doesn't affect his argument so much. And actually, it seems like kind of an isolated demand for rigor to ask that he does this when writing a popular article about this topic, when almost nobody in the social scientists do that in the corresponding situation. So okay, that's that. I want to go on and discuss whether we see signs that the respondents have thought carefully about AI futures, whether their responses to the questions are well considered, or maybe they are not. And I think that there are many signs that they haven't really thought very carefully about these things. And already in the 2016 survey, there were strong indications of some very strong framing effects, meaning that the equivalent ways of formulating a question can have a strong effect on the answers. And I consider it to be one of the great strengths of these surveys, that they look for these framing effects to get a better view of the reliability of the answers and so on. And then they talk about them in the reports. And here's one thing. So when these researchers are asked about timelines until, for instance, high-level machine intelligence, there are two different ways, natural ways to formulate such questions. So it's all about in what years do we have what probabilities and so on. What you can do is fix the probability level and ask, by what year do you estimate an X% probability that AI can perform task T? So that's fixing the probability and asking for the year. But you can reverse that and fix the year and ask for the probability. How likely is it, in your opinion, that AI will be able to perform task T by the given year Y? And knowing the answer to A for all the various probability levels X, and knowing the answer to B for all the different years Y are equivalent. Now, I mean, for practical reasons, you will only sample a number of such points, in this case, 3 different points for each respondent. But that does give plenty, basically enough information that further inquiry is not so meaningful. But it turns out that phrasing the question in the second way, fixing the year, consistently led to much longer timelines than phrasing it in the first way, fixing the probability level. And the effect here is not subtle. The effect is large. One can wonder why that is. And although there is some discussion in the report, and Katja Grace has talked about it in podcasts, and she actually in 2017, she gave a talk at a meeting that I organized in Gothenburg, where she talked about this, and I recommend, if you're interested, you can watch this on YouTube. But one, I think that it's reasonable to say that if respondents had carefully considered views on these timeline matters, we would not see such strong framing effects. If I understand the topic really, really well, then I'm not going to respond differently depending on the exact wording of a question. I have my personal guess about why we get this particular discrepancy and the direction it takes. And it's about respondents not wanting to sound far out and influenced by a science fiction kind of way of thinking. So if we begin with phrasing B here, how likely is it that AI can do such and such things in the year 2050, for instance? if you have this social bias in sounding like a science fiction nerd, then you will want to keep that probability low. On the other hand, with the other kind of, so that leads to longer timelines. But if you are asked to give a year when there is such a large probability, then at least superficially, it sounds less science fiction-like if you give a lower number of the year rather than talking about, I mean, only crazy science fiction dudes will talk about what happens in the year 2300 or something like that. So they will give a near year, and that leads to shorter timelines. That's one possible mechanism. I don't know if I'm right here, but it seems to me plausible that something like this could lie behind this particular framing effect. So that's from the 2016 survey, but in the 2022 and 2023 surveys, these framing effects have remained. And as I said, the effect is not small. So in the 2023 survey, the median time to high-level machine intelligence is estimated at 17 years if we fix probabilities, and 34 years if we instead fix the years. So this, I mean, it looks like an innocent framing thing we're doing here, but it's a factor 2. It produces a factor 2 in the estimated time until a particular research breakthrough. Okay, so that's one thing. There are a bunch of other stuff in the outcomes of these surveys that I think merit our attention and suggest that the respondents have, at least many of the respondents, have not thought very carefully about these questions. Let's look again at this curve of the cumulative probability distribution for when we reach high-level machine intelligence. I gave you the definition here. The machines being able to accomplish every task better and more cheaply than human workers. Now, this is about tasks, and you can ask a closely related question regarding not tasks, but jobs. And the concept here used in the surveys is what they call FAOL, full automation of labor market. And they define this also very closely. Say an occupation becomes fully automatable when unaided machines can accomplish it better and more cheaply than human workers. Ignore aspects of occupations for which being a human is intrinsically advantageous. The same jury member stuff as with high-level machine intelligence. Think feasibility, not adoption. And then we say we have reached full automation of labor when all occupations are fully automatable. That is, when from any occupation, machines can be built to carry out the task better and more cheaply than human workers. And one would think that automating every human task and automating every human job would be very closely related, because jobs consist of various tasks, and if the machines can do all the tasks, then surely they can do the job, one might think. But look at, compare these curves. The time until full automation of labor market, the times are much longer compared to the time until high-level machine intelligence. And if we look in particular at the median estimate of the time of reaching these milestones among the respondents, the median year becomes 2047 for automation of all tasks. and 2116 for automation of all jobs. That gives a 69-year gap between first getting machines capable of doing all our tasks and the machines being capable of doing all our jobs. Because remember again, it's not about actually implementing this all over the labor market. It's just that when does it become feasible? So this 9-year gap cannot be explained by like achieving this capability in 2047 and just holding back for various labor market reasons from implementing it for the next 69 years. That's not what this is about. It's about being capable of automating all tasks in 2047 and then being capable of automating all jobs only 69 years later in 2116. And I mean, that's a really strange thing to think about, because once you have machines that can carry out all tasks, then you look at a particular profession, such as my own, being a university professor. There are various tasks in my profession, which by 2047, the machines can carry out all of them. But in order for what would prevent them then from taking over my job? Well, it's some kind of some master mechanism for choosing which task to carry out in which situation. But that's also a task. So this really doesn't make sense. And if it was just a 1 or 2 year gap, maybe okay, but almost 70 years. That's weird. But I think that my question here about how the respondents are thinking here, and of course, there needn't be any single respondent that hits the median in both of these numbers, probably not, but there's going to be a lot of respondents that have many, many decades. This needs to happen for these results to come about, that have a gap of many, many decades between these two benchmarks. How do they think about it? I think that they don't think about it at all. They are asked questions about these thresholds, and I think most of them, maybe all of them, are only asked about one of these thresholds due to this random selection of subset of questions for each respondent. So they're not triggered to think specifically about the distance between these two events. But then we're again in a situation where, if they think, as I think would be reasonable, that these two events would more or less coincide, then talking about HLMI versus FAOL is a very strong framing effect. There's actually one other question being asked in the survey that does ask specifically about the what happens in the years after high-level machine intelligence. The question is about what happens 2 years and 30 years after the HLMI breakthrough, regarding, they're asked for the probability that the machines will be vastly superior to humans 2 years later or 30 years later. And actually, responses to those questions, I don't have them now off the top of my head, but they are crazy low. I think that the idea that 30 years after high-level machine intelligence, we wouldn't have machines that are vastly superior to humans, whatever you mean by that, is if you think that that will not happen, that you really haven't thought through what HLMI would mean, for instance, in terms of accelerating further AI development. So this is a bit of an anomaly. Here is something else. Here is a question specifically about extremely bad outcomes of an HLMI breakthrough. In the long run, this is the first way to phrase the question, and they put human extinction in parentheses in the questionnaire. Then there are a bunch of variants. Question 1, what probability do you put on future AI advances causing human extinction or similarly permanent and severe disempowerment of the human species? And question 2 is the same as question 1, but they are asking also that this involves human inability to control future advanced AI systems, that this causes human extinction or similarly permanent or severe disempowerment of the human species. So these are almost the same question, but question 2 adds the proviso that humanity loses control. It's very hard actually to imagine the scenario in question 1 happening without the humans first losing control. But maybe, I mean, maybe it's logically possible to construct such scenarios. And then the situations would be actually different. But that would then lead to a higher percentage of yes answers to question 1 than to question 2. I should add that these are among the participants who give a 10% or higher probability of an extremely bad outcome. But the discrepancy here, since the requirements in question 2 are stronger than in question 1, the discrepancy should go the other way here. Maybe the difference between 51.4 and 47.1%, this is like borderline explainable as a statistical fluctuation, especially if you take into account multiple inference questions. But then we have this much bigger discrepancy if you compare it to the first question here. Let's ignore the last one, question 3, which is the only one that incorporates a time aspect here, and just compare the 51% probability in question 2 to the 37.8% in this question 0, we could call it. And the discrepancies here compared to this one and this one is, I mean, those of you who are familiar with the literature in cognitive psychology about cognitive biases may recognize this as a case of the conjunction bias, which became famous through the so-called Linda problem in a paper by Kahneman and Tversky in 1981. So here, respondents are given a description of Linda, which is taken to be true. Linda is 31 years old, single, outspoken, and very bright. She majored in philosophy. As a student, she was deeply concerned with issues of discrimination and social justice, and also participated in anti-nuclear demonstrations. So if you take this as your prior knowledge about Linda, and as a respondent, you're asked to rank the following statements from most probable to least probable. And the interesting thing here are cases, statement 6, that Linda is a bank teller, and statement 8, that Linda is a bank teller and active in the feminist movement. And the point here is that, I mean, all the other 6 statements are just there to hide to the respondent the point of the exercise. So the important ones are 6 and 8. And if you're rational, the authors claim, then you ought to give a lower probability to Linda being a bank teller and active in the feminist movement compared to just asking the probability that she's a bank teller. But the study showed that 89% of respondents ranked 8 as more likely than 6. And you can speculate about various reasons for this. I mean, being active in the feminist movement is in such good agreement with the background description that it's taken as kind of, yes, this fits very well. This seems likely. Some have suggested that respondents would interpret item 6 as Linda being a bank teller and not active in the feminist movement. And it doesn't say that, but that could also be because of the presence of item 8 here. They might interpret it that way, but the corresponding. So this is supposed to be an example of this general phenomenon of people estimating what is the probability that this and this and this happens compared to just one of these things, compared to just asking whether one of these things happened. They give probabilities the other way around. Adding more detail to a story increases in people's mind the likelihood of the story, counter to basic probability theory. And there's something like this happening in the Katja Grace study. But a difference here is that in the Kahneman and Tversky Linda example, the respondents are asked explicitly to compare these two outcomes. And here we have different sets of respondents to the different questions. So they are not asked for specifically a comparison between the two cases that might have given a different result. But in my view, this strengthens the case that the framing of questions has weirdly large effects on responses. I want to mention one more thing, which is less of like an outright logical contradiction in responses, and more that something that I personally consider still quite weird. And this is the question of what the respondents think will be the overall impact of high-level machine intelligence, given that we achieve it in the long run. Will it be good for humanity, or will it be bad? And here are the means, and whether you look at the means or the medians, but it's more clearly seen among the medians, you see a push towards the middle of the distribution. Fewer people talk about extremely good or extremely bad outcomes, and more people speak about neutral or adjacent outcomes. To me, that suggests that they haven't really thought about how extreme the situation with high-level machine intelligence would be. I mean, imagine having machines that can carry out all human tasks better and cheaper than we human can. That's a huge change to the fabric of society. And the idea that by some weird coincidence, this would lead to a cancellation between the positive and negative effects so that we land somewhere near neutral. That to me sounds very strange. It's actually, the responses here are similar to what you get when you ask the general public rather than AI researchers. So here's a recent Swedish study where the respondents get the same question about the positiveness or negativeness of impact on humans of AI development. And this is very strongly tilted towards the middle. Here's the neutral state, which was 32% in 2019, and it's even much bigger in 2023. And I think that this is just very unlikely. I would put most of my probabilities on the extreme cases here, positive or negative. But compared to this question, which is unconditional, what do you expect from AI development? We have in the Katja Grace study, they ask about what do you expect conditional on achieving high-level machine intelligence. And that makes the majority of more or less neutral answers even crazier in my mind. And again, this to me is a suggestion that the respondents receive questions to issues they haven't really ever paid any serious thought to, and they just answer something. They want to answer something reasonable, and when you're asked if something is good or bad, it's usually reasonable to land somewhere in the middle. So they do that without much further thought. And well, there are other anomalies in the responses to the Grace service, but I think that we have seen enough to conclude the following. I think respondents to these surveys exhibit so strong framing effects and so much other confusion that many of these respondents cannot possibly have thought seriously about AI futures. And this actually has some, if this is right, I think it is, then it may have some consequences for the claim quoted by Tegmark that 50% of AI researchers think there's at least a 10% chance of extinction. It seems to me quite likely that actually it's not the case that 50% of all AI researchers have a firmly established belief that this is the case. I mean, if they had, I think the natural reaction here is to freak out and to decide that we should stop from doing this general AI development and shift all our attention and resources to AI safety. But we don't see much of that reaction, and we don't see much of, I mean, most AI researchers seem not to care very much about this AI risk debate. And this, I think, is best explained by them not really having any views at all on issues about AI futures. And what do you do when you don't have any views on a matter and you're asked to answer a questionnaire? Well, you try your best to quickly come up with answers that sound kind of plausible, but without thinking too clearly about them. And I think if this is right, it's an important finding. I mean, anecdotally, this rhymes perfectly with my own experience of the AI research community, that most people just don't think about these questions. It's not that they reject the questions, that it just never enters their mind that this is something that they ought to think about. But it does undermine the idea that I touched upon in the beginning, that these studies would give guidance on what AI developments that the future has in store for us. I think that these studies say rather little about those questions. So they answer kind of sociological questions about the AI research community, but they don't really answer the futurological questions about what kind of technical development we can expect in the future. But if we want guidance on what the likely futures with AI are, where should we then go instead, if not to these surveys? And I would say, don't primarily ask these mainstream AI researchers. I mean, what they say, at least what some of them say, can give some interesting insight into these questions, but it's going to be far from the whole story. And a much more relevant thing is to, if you make a serious effort to find out what people working seriously in AI futurology think about these matters. Now, this is a much smaller research community, so it makes less sense to do statistical surveys about what they think. I think that there's what one needs to do is to just look at what the individual AI futurologists thinks, and most importantly, look at their arguments, look at the reasons they have for their positions. And when I talk about AI futurologists, what I have in mind are people like Ajay Kotra, Tom Davidson, Joe Carlsmith, Carl Schulman, Nick Bostrom, also Katja Grace, by the way. And one name that was very early in this discussion, and which I tend to be somewhat dismissive about, is Ray Kurzweil, who wrote in his 2005 book, The Singularity is Near. He made very confident predictions that we would have a singularity in 2045. And he had such extreme over-precision in his timelines and so on that it was very difficult for me to take seriously. But when looking back at how his various other technology predictions have turned out, he has fared fairly well. So maybe we should include him in the category of serious AI futurologists to pay attention to. Now, it's not easy for the individual layman to go directly to these various people, so we need summaries in various secondary sources and so on. So where would I direct people? Well, one source here, one kind of source, which I think at present really thrives and is podcasts. Someone who's into listening to podcasts has really a gold mine of very useful information here. And there are various fairly technical AI podcasts that use a language and the depth of issues that it's maybe not so suitable to most laymen. But there are in particular two podcasts, the 80,000 Hours podcast and the Future of Life Institute podcast, that combine taking these AI futurology questions very, very seriously, talking to the best experts in this field. They combine that with an accessibility, which I think is quite remarkable. And if you want to start in one podcast episode, I would recommend the interview that the 80,000 Hours podcast did with Ajay Kotra in last spring, which is very. Once you've heard that, you can go on to other episodes of the same podcast and fill in with further insights. But this is a really excellent place to start. And Ajay Kotra is as good an expert on AI futurology as basically anyone, I would say. Another source that has helped me quite a lot over this last very dramatic year, 2023, is Zvi Mowshowitz's newsletter, Don't Worry About the Vase, which he publishes as a blog and a Substack. Now, this is mostly for those of us who want to keep up with these very, very rapid developments. And if you want to build sort of your own knowledge base, maybe you want to start with a book that just calmly tells the story. So what books are there that can help us with AI futurology? There are a few classics, the two best one, and I think it's fine given the way the extreme pace of progress now to call a book that is just 10 years old a classic. Nick Bostrom's Superintelligence. It's fantastic. And Stuart Russell's Human Compatible, which came 5 years later. These are two of the absolute best books on what to expect from AI futures that are out there. But they are already a little bit dated. So much has happened even since 2019 that if you only read these two books, you won't be particularly up to date about how to think about these issues. If you read Swedish, you could complement this by my latest book, Tänkande Maskiner. The first edition was published in the spring of 2021, but I quickly saw the need for revising it and adding insights from these very rapid developments that happened over the next 2 years. So there's a second edition from 2023, which includes a long chapter on these developments and how to think about them. So really, for those of you who read Swedish, I think that it might be worth having a look at. There's another 2023 book by Darren McKee, which I actually haven't read, but McKee appeared in the Future of Life Institute podcast recently. They talked about the book and everything made so much sense to me that I feel like it's warranted to say that this is probably a very good book, despite the somewhat gloomy title. But it's a fact, I would say, that we are in a very, very dire and serious situation as regards AI risk, and we need very much to pull ourselves together to solve this collective problem of making sure that that the big AI breakthrough doesn't lead to global catastrophe. That was what I was planning to say today. So thank you for your attention, and see you around. I'm sure I will be back with further videos in due course.